shall refer to you all as team because that is what I'm more used to. And as far as the session is concerned, what I wanted to do was reflect upon what emotions and understanding budding students like you would have vis-a-vis all the hullabaloo about AI and agents and enterprises, giving due importance to the fact that a lot of what you may be exposed to would be limited in terms of what actually happens in enterprises and how enterprises adopt these technologies, and therefore how it affects you from a career perspective. Now, I do recognize the fact that we will have a wide range of skills attending this session, and this will be limited not only to computer science professionals, but people from other work streams as well. So I will try not to go into all the details, the gory details of AI per se, but feel free to ask me any detailed realization kind of questions later on towards the end of the session. But as far as the flow is concerned, I have been told that you all have already been exposed to some of the fundamental principles of these agentic systems. Now that presumes that you all understand basics of neural networks and deep learning techniques, moving on to concepts of foundation models and the transformer architecture that forms the foundation of these foundation models, so to say, and onwards into how to build these agentic systems and what that really means. However, I shall try and revisit some of these concepts as I go through the other topics of this session. And how I want to build this up is as follows. First, I would like to contextualize the impact of technology in general and this transformation that we've been witnessing, both from a personal or a consumer retail point of view as well as from an enterprise point of view. Uh, Go
Sorry
a
to
little deeper
interrupt.
in.
Actually, your screen is not visible, Adarsh, sir. It's black.
Let me try and
Can you just
reshare the
reshare? Yeah.
screen.
Yes.
Yep. Is this visible now?
Yes, it is visible now. Yeah.
Fine, fine. So as I was saying, I shall contextualize the transformation journey that we are currently going through. Talk about the impact of AI in general on enterprises and how they're leveraging these capabilities to transform themselves, and then move into trying to help you all visualize how enterprises operate in the real world in terms of their processes, and thereby which processes have a greater affinity towards these agentic systems, because it is these processes against which you will be trying to prepare yourselves as you go through your academics and are ready for your internship as well as your actual jobs that you eventually would be working in. And then I shall, talk about certain preparation inputs as well. However, let me emphasize that these shall not be prescriptive inputs. I shall, however, give you certain guidelines that you all will have to process yourselves and make your own decisions as to how deep you want to go to in a particular subject area, and that will be dependent on your own preferences itself. So, moving on to the first slide, wherein what I want to emphasize upon is that while we are all anxious about how this current technology wave is going to transform not only our lives but also our careers and our job prospects, it is important to understand that this is not the first time that we are witnessing this. So we've been going through a number of similar revolutions, starting with the first, second, and third, revolutions, which coincides or is reflected by things like the invention of the steam engine to electricity to the creation of computers, the World Wide Web, so on and so forth. Right now, if you see, we have been looking at um, we have been looking at AI and data, which is a result of the fact that we've adopted digitization and internet technologies and mobile telecommunications at a wide scale, and therefore that has led to a plethora of not only data, which is not easy to process manually, and therefore we use various statistical algorithms, etc., to try and harness the insights from that data. But we've now moved on to the agentic world, wherein we allow these systems to kind of operate semi-autonomously or autonomously towards achieving a certain objective. Now, as we all would appreciate, this is becoming increasingly relevant, obviously, because of the extent of data available and the complexity of the permutations with which you can use that data towards arriving at an output. And we'll go into certain examples to make this more clear. But what we must finally appreciate is that as these transformations have occurred in the world, and affecting not only how enterprise operate but also how we conduct ourselves, the duration of these changes has been diminishing. So if it took, let's say, 30 years for the impact of let's say the internet to be actually witnessed in the economy, it is taking much lesser time right now, and going forward with these new technologies that we are seeing becoming mainstay in the ecosystem. And whatever the transformation, whether it is the internet or the World Wide Web or the creation of GPUs and TPUs, etc., all of these have led to economic growth at one end, and at the other end it has caused us, or it has disrupted the old way of doing things. So whether it was the business models that used to define how companies used to operate in the market, to the skills that were required to harness those technologies, to even the ways of working. And as a result, whole industries have transformed, and they've transformed into newer industries. But central to this is that as the impact of these changes are understood and made correct use of, it is the identity of work that has changed. So, for example, gone are the days that you would be expected to learn how to operate a particular consumer's website. Instead, you would tell that the consumer services providing company what you want, and the consumer services providing company would understand your intent and give you what you want. So what that reflects is, and we'll go into this detail a little further as well. As an example, if you're looking at operating your bank account on your banking provider of choice, and you go to their website, you would be familiar with various options, menu options being provided to you, and you having to know upfront where to find what you need to do. So, for example, if you're creating a fixed deposit, you will need to know how to traverse through the menu options to actually go and reach the objective that you want to exercise, right? This experience is changing and will change to allow us to be more effective in what we need to do. So instead of having to go and traverse through the maze of menu options, you would probably just provide a command and say that create a fixed deposit for me, and then the underlying system would take that request or that instruction and do the needful and give you a success message or a failure message. uh, you know uh, um, uh, in an attempt to meet your objectives. So the nature of work is what is going to change, and therefore we need to adopt these new ways of working, as well as learn the skills that are required so that we are better prepared to use these technologies as we move forward. And this is relevant not only from a personal point of view, but also from an enterprise point of view. And even if you correlate this to larger entities like governments or regions, etc. In the sense that even enterprises cannot afford to just wait and watch and learn after others have taken the plunge and have learned to harness it effectively, because they will basically miss the bus. So the central message I want to convey is that these technologies are here to stay. These technologies have defined how enterprises have transformed and will continue to exist in the future. And therefore, we as consumers or creators also will have to adopt these capabilities. The next slide talks about or tries to emphasize this central message, in the sense that what what we're trying to suggest is that um, enterprises have leveraged technology, and software is one form of technology, to be able to automate and make their processes more efficient. Now, as time has passed, they have tried to automate certain parts of their existing software to improve the efficiency. And as they have done that, they have realized that the processes that these workflows represent, which is under the hood represented by code itself. So as they have, adopted more technology, adopted more workflow-based systems, adopted more automation-based systems, their processes have improved. And as the processes have improved, the enterprises themselves are better equipped to face the competition in an increasingly competitive world. And it is not only the enterprise themselves as an entity obviously has transformed, but it is also the people and the culture that has changed. So, uh, uh, the following section, which talks about, the enterprise success being determinant on the processes and the value streams that define the enterprise, is just trying to convey the point that um, the existence of an enterprise or the success of an enterprise depends on the value it creates, which may be either some innovative product that they bring to market, or an innovative way that they have orchestrated their processes. And if you think of it, one of the enablers of orchestrating the processes in an effective way is technology. And as time has passed, wherein the amount of data representing these processes has increased, the requirement to use analytics in general to be able to harness this data representing these processes, the need to use AI for that has increased. And as we have matured in that journey of using AI, we've also realized that the workflows that we had developed previously, which were more or less static and hard coded, we now have the possibility to leverage the capability of reasoning engines realized by the foundation models to be able to make those workflows more dynamic. And that is what is represented by the agentic AI world. And this agentic AI world, therefore, has transformed and will continue to transform not only the traditional industry-based organizations across different sectors, so whether it is banking and finance or retail or FMCG companies, etc., or the core tech industry, basically, which I, for example, represent, or even the new converged industries or companies that are taking shape. So the fintechs of the world, the agri-techs of the world, all of them, number one, have adopted technology to improve their outlook in a competitive market, and are increasingly using automation, AI, and agentic AI to improve their prospects in a competitive world. So I'll move to the next slide, which talks about the reality of how we are seeing these agentic systems already taking shape in the software and products that we bring to market. So, if you look at the domain of SRE agents, which refers to software reliability engineering, system reliability engineering, which basically talks about ensuring that systems are always available and what you would need to put in place to ensure that if there are any defects or a degradation in performance, you take the necessary course correction. So these kind of capabilities are being now inbuilt into systems, leveraging these agentic capabilities so that the system itself is more performant. Similarly, you may be aware of software engineering products and technologies, which allows you to. I mean, you've heard of things like co-coding or vibe coding, etc., or using these code assistants to assist you with your coding activity. So we are seeing that these capabilities of automating the activity of creating software components is also being realized and it's becoming mainstay. These capabilities are also therefore being embedded into various package-based applications, which remember represent processes of companies. So if you take examples of CRM systems like the Salesforces of the world, or the erstwhile Siebel, which is now owned by Oracle, etc., or the ERP systems, even they are adopting and embedding these agentic capabilities within their systems to automate various workflows. And obviously, robotics is a given. Now, the implication of this is that this is transforming the so-called human-machine interface in the sense that the interactions that we used to have with computer systems or machines is now becoming more concise, is becoming more effective, as well as is becoming more automated in the sense that it is becoming limited in terms of the instructions that you have to give because these systems are becoming more automated, given or premised on the fact that you enable these systems to take necessary courses of action. And by taking necessary course of action, what I'm referring to is that you give them the tools or the avenues to do certain tasks. Now, this obviously is again premised on the fact that how do you communicate? I mean, you communicate either through your verbal means or through gestures. So therefore, multimodal perception is becoming very important. So you not only take uh, uh, cues or inputs in a textual form, but you also look at signals, whether it be audio signals or it may be visual signals, and use all of them to then make certain decisions that will allow you to accomplish certain tasks. So these are becoming more mainstay as well, and especially, I mean, specific examples are in any manufacturing process, which requires observability of these systems to detect failures, for example, or to detect deterioration in performance, for example. There you are seeing these capabilities becoming mainstay. These obviously result in productivity gains and efficiency gains, uh, because as these systems become more autonomous and make decisions themselves, the human factor or the delays caused by humans is removed. Now, obviously, I do not want to sound as if I'm undermining the capabilities of human beings because we have something that is largely unreplicable. However, the caveats or the misgivings that we have, which make processes more elaborate or time taking, are being addressed by these systems, of which agentic AI is one such enabler. I'll quickly move on to the next slide and I'll just do a quick time check as well. Fine. So the next question that you all may have is that how is this being, manifested, or how is this being realized physically or in a real world, right? So um, what you all must appreciate is the older way of how we would work. So the typical way in which we would build software systems which would replicate or represent processes which we're seeking to automate is as follows. We would work with the customers who would provide their requirements. For example, let's say that we are trying to automate or codify the invoice processing workflow. So we would work with the procurement guys and understand from them as to what it takes to process an invoice, and those instructions were given to us, and we would replicate those instructions as pseudocode and eventually as code, which would then form the system that we would deploy and automate the process. So this is the typical erstwhile way in which we would build application systems, whether it is custom applications or package applications, and deploy them in customer environments so that they can automate or digitize their processes. What you would realize, therefore, is that these systems, because they were replicating rigid workflows or requirements given by the requesters, which is, let's say, the procurement guys in this case, they would conform to very rigid workflows of inputs, processing, and then outputs. This is now being changed to the more agentic systems, wherein number one, you have or you leverage the knowledge base of the foundation model itself, which has been trained on information reflecting various processes, so including a procurement process. Now, you would argue that, hey, a procurement process is standard, but the way in which a company X would implement that procurement process would be slightly different. And I agree with that. And it is for that you would do some customizations. But essentially, you are leveraging the power of the foundation model to also represent that process, a workflow, but you would therefore build systems that are modular in fashion, um, and would be able to be called or stitched together in real time depending on the kind of inputs. So what is that? I mean, let's take an example to understand that better, right? So for example, if in the previous case, let's say a procurement person came to us and said, hey Adarsh, we get invoices from a supplier A, and these are the steps that we undertake to process that invoice. And we would then mimic or codify the way in which that invoice is processed in the form of code. For a supplier B, which requires a certain variation of the processing steps, we would repeat that process for supplier B, and so on and so forth. And as a result, we would create several such workflows reflective of the different suppliers and the nuanced way in which the invoices from them would be processed. However, as we move from these fixed workflow systems to agents, to single agents, and then to autonomous and multi-agentic frameworks, you would all you would need to do is provide an invoice and not necessarily give an instruction that, hey, this invoice has come from supplier A, so therefore please apply the rules which are specific to supplier A to process this invoice. Instead, what you would do is that you would define whatever rules are required for processing that invoice as a tool or an agent, which would be then called depending on the kind of input that is received. So if you look at this workflow over here, what is happening here is that as an invoice is received, you have an agent called an invoice processor, which whose task is to understand who the layout of that invoice to be able to classify or determine which supplier this invoice has come from, and then call respective supplier specific agents to process that invoice. That is one example. The other example is that uh, to process an invoice, there is a series of tasks which kind of leverages various capabilities of AI. So if it is to do with information extraction or the OCR capability, you would leverage various algorithms to be able to do that. So instead of rigidly stitching those pieces of code together, which would then break if there are certain variances in the format of that invoice, you would instead create separate agents which would represent separate functionalities or separate processing capabilities, which I just talked about, like the text extraction capability or the OCR capability, for example, and you would deploy them as individual agents to be called depending on the layout or the nature of the invoice. And those agents would then possibly collaborate with each other and the central agent, which will determine whether the processing has been completed and whether it has been effectively completed or not, and then provide a response to the end user. So I hope I'm able to pass on the message or the experience of how rigid frameworks are now becoming more flexible and dynamic frameworks. And I hope it is becoming apparent to you and obvious to you that what are the advantages of such a setup in terms of the flexibility of calling these modular systems based on the reasoning engine which is represented by the foundation model. I uh, just want to check if I'm still audible and uh, we are doing okay with the.
Yes, yes. Audible.
Fine, fine,
Yeah.
fine. And I know I have just 17 to 20 minutes left, so I'll try and
Sure.
speed things
Yes.
up. So the following slide tries to bring this point home in the sense that what you have on the left side is an example of a typical RAG agent. Now, I mean, I won't go into details of RAG for the purpose of a wider audience, but suffice to say that if you were to retrieve information from a corpus provided, so that your insights are more grounded, the traditional way of doing it, leveraging generative systems, was building a system that stitched together the various parts of retrieving that information from a corpus rigidly. The challenge with this system is that if the information that you are looking for is not in this knowledge base or is in some other system, you would have to add that system to your original workflow or your the way you stitched your pieces of your code together, so on and so forth. And as these systems would increase, your code would be hard to manage and handle. Instead of this experience, if you're leveraging agentic systems, for example, you would define or expose the data that is required for certain tasks upfront, and you would leave it to the orchestrating agent to determine which system you need to go and retrieve information from to be able to do or perform certain tasks. So uh, I hope you're able to see that because of this capability, you are now allowing the assembly of modules to be more dynamic in nature instead of it being hard coded and dependent on a single workflow, which you then have to go and modify multiple systems depending on your requirement. So the example out here is just trying to bring the point home, wherein if you read this, the first question revolves around what uh, a technician should do to troubleshoot a dishwasher which is not draining properly. And therefore, in order to answer this query, the system would go and look at troubleshooting guides for a particular dishwasher and provide a response. However, if the question is more complicated, right, and obviously this is how we generally operate in the real world, right? My question may not be, containing a single intent or a single objective. It may contain multiple objectives, which you see in this question, wherein the question is, what are the likely root causes of the dishwasher not draining, and what steps should I take based on the current stock and service history and time to repair? So what this question is asking is that, uh, first go and find out what are the troubleshooting mechanisms that I need to follow to repair my dishwasher in terms of allowing it to drain completely. And by the way, also look at my service history for this particular dishwasher or washing machine or whatever the machine you're talking about, and check whether I also need to have it repaired or serviced. And for example, if I need a part to repair this system, is it in stock or not? Now, this obviously is a more complicated query and will require you to retrieve information from a number of systems, which is not limited to just the troubleshooting guide, but also, maybe your supplier ERP systems, which provide you inventory details of whether a part is in stock or not. Similarly, it may require you to go and probe or query a incident management system that records the time to repair this anomaly or this issue with the dishwasher. So, uh, what you need to visualize and be able to appreciate is that this question is a multi-step question. It will requires a hierarchy of sub steps to be followed, and to codify this in the normal way would require you to implement, hundreds of lines of code, and it would be very brittle. And instead of that, you would, leverage the capability of these agents to be able to respond to such queries. And I hope the benefits of such a system is apparent to you all. So I'll move on to the next slide. So what we should also appreciate is that building such systems, uh, irrespective of the benefits it provides, is not simple. You would have experienced this while using the ChatGPT 2 years ago and looking at the ChatGPT of today. Also appreciate and remember the fact that consumer oriented systems, are more flexible or can be, in the sense that you can do with mistakes being performed by the system, right? Like, for example, if ChatGPT gave you an erroneous answer or hallucinated, you would just move ahead. However, in a enterprise scenario, uh, accuracy is paramount, and the failure to achieve those SLAs or performance metrics, leads to, challenges which are hard to address, right? So, as a provider or a vendor to a particular client, if we provide a system which hallucinates or does not give accurate answers, we get penalized. So what I'm trying to make you appreciate is the fact that while these agentic systems provides us with certain capabilities, being able to harness it to its true potential is tough. However, the benefits are many, and this chart is providing you with a glimpse of the top benefits that are realized through these systems. And this was a study conducted by IBV, which is a research arm within IBM itself, which looks at or talks to a number of CXOs and CEOs of companies, and based on that derives these metrics. So you would see that these systems allow improved decision making and being able to derive insights from data, and therefore uh, allowing enterprises to reduce costs by automating manual tasks. Uh, Having talked about the benefits, what we must also appreciate that there are certain processes which are more which have a higher probability of benefiting from these systems. Now, if you think of it, um, what are such, and if you ask yourself, what are such systems? The first, pointer that you should get is that these are systems which have a lower risk or a risk exposure in terms of failure. So, for example, if you are looking at, let's say, treating a particular patient, and you make a mistake, the risk of failure is much higher over there. So you would try and address processes which have a lower, risk exposure to issues of inaccuracy. You would also look at processes which have a high volume of information, especially in the unstructured area, wherein these capabilities of agentic systems and especially foundation models, uh, 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 you know, uh, the success level is much higher, or the capabilities are much more refined for addressing such complex scenarios. So what we're seeing is that the first movers or the first adopters are in the areas of research, and even compliance, customer service. So this is your usual call center kind of operations, wherein we are building systems that respond to customer queries or in autonomous ways, and we're now using agentic systems to address the outlier conditions which we were not able to address maybe a year before using deterministic workflows. We're also looking or seeing early adopters in the area of supply chain, logistics, and fulfillment. And again, this goes back to the example that I was providing in terms of invoice processing. So whether it is purchase orders or invoices, you can use the capability of AI and as a continuum, AI and these agentic systems to automate a lot of these processes in these supply chain systems. And then you have the sales and information technology and so on and so forth. But suffice to say that as time progresses, the penetration of these agentic systems across these industries is only going to increase. uh, there are, however, obviously certain concerns and challenges that we face. So, number one, you must remember that these agentic systems are built on foundation models, and you would know that out of these foundation models are trained on, number one, open source data, and then data which is scraped from the internet, and then some proprietary data. However, very few, I mean, proprietary models do not expose the data that the models are trained on, and certain open source or open weight models do provide some details of the kind of data. Like, for example, IBM provides or is completely transparent about the data that it has used to train its Granite models. However, for enterprises which are in heavy regulated industries, it is a risk exposure for them. So there are concerns around the intellectual property. Also, in the case of agents, remember that in a best case or a futuristic scenario, you would look at a environment in which you would dynamically invoke agents not only created by you but also by third parties, wherein you would integrate with external systems to use their agents. So there are questions around who bears the cost of invoking those agents which are not owned by you, so on and so forth. So there are still certain concerns which are being ironed out, and there are protocols, etc., which are being framed in the industry to address these areas, but there's still work in progress. Then there is the accuracy, the concern around the accuracy and bias. Now, this is a very I mean, it is a very real and a very challenging aspect to tackle. There are techniques that are being applied, but they are very use case specific. So, accuracy and bias is an important factor that is being looked at both in research as well as across enterprises which build such solutions. And then there is the concerns around the privacy and confidentiality of data. I'll move ahead to the next slide, which tries to contextualize the challenges that we are facing while building such systems. So what you have out here in this architectural blueprint is a depiction of how these generative systems, which is a small component of a multi-agentic system, works. Um, just to give you an overview, what this is trying to show is that an invoking process with the input basically triggers a call to a foundation model for a response that is then used by the invoking process. It is as simple as an invoking process asking whether, for example, this invoice has been processed or not, or whether this invoice belongs to supplier A, right? It can be as simple as that question. But in order to process that query or that function, you might need to um, execute many other processes, like, for example, enriching that request with certain ancillary information, which may be uh, 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 acquired from external systems or internal systems. You might need to cache that information so that repeated requests can be made more efficient and faster. You may need to process that request. So you pre-process that request before you make that call to the large language model and you get a response. You may need to also then post-process the output itself. Um, and if you focus on these annotations, these abbreviations A, B, etc., you will see that these refer to guardrails and other agents or tools or functions. Now, think of this system, right? What we are trying to suggest and trying to, pass, the message we are trying to pass on is that in order to realize these systems, you also have to bring in further guardrails or checks and balances in order to ensure that your agent behavior, for example, is predictable, or the paths that have been taken or traversed by the agent in a dynamic workflow is the right path that should have been taken. So that refers to the observability capability or what has been done, etc. The evaluation refers to whether those steps that the agent has taken are actually what it should have taken or not, whether the response given by the LLM is correct or not, so on and so forth. So what we're trying to say is that all this instrumentation that is required to make a system that is production worthy and scalable is not trivial. And sometimes this maybe, and you may realize that in order to implement these capabilities, the system itself may become non-performant. For example, if you apply too many checks and balances, your latency will increase, right? And there is no use of getting a response after the effect or after a particular event has happened. So I hope you all have been able to appreciate the fact that while these agentic systems provide us with a lot of opportunity, there are various challenges that we are encountering and we are trying to address in order to harness the true capability of these systems. Now, that is from a technical perspective, right? So let us move into the business world of things. Now, as I told you, the enterprises that exist are reflective of the processes that are implemented in those enterprises. So, for example, an enterprise in the healthcare sector have a certain set of processes which are specific to the healthcare world, right? So, for example, this diagram is trying to show you a quick snapshot of what processes are relevant to the healthcare industry. So you have the common processes like financial management or business operations, etc. And then you have healthcare specific processes or operations like clinical care, and so on and so forth. This has been further subdivided or categorized into whether these processes are strategic or not. Uh, it is not important for y'all right now to understand each of these processes, but what I want you all to take away from this is that there are certain processes which you will see in dark blue, which are more tuned uh, to uh, be made more efficient by leveraging these agentic systems. So, for example, if you look at the regulatory and compliance process, for example, in the clinical care world, before you come out to the market with a particular drug or a treatment, you need to follow certain regulatory protocols, and for that you need to create a lot of documentation to be able to adhere to and prove that you are meeting those regulations or not. This is very time taking and requires people of high expertise to not only understand those regulations but also create those reports which allows a company to comply with those regulations. Now what we are seeing is that leveraging the reasoning capability of these foundation models and the generative capabilities of these foundation models. So reasoning to be able to understand the compliance requirements, generative to be able to use the details of what you have followed to produce a particular drug or a new treatment, for example, compared with the regulatory requirements, and create the documentation to prove that you are complying with those requirements. So the generation part of it, you can now create it and automate that process, right? Through or leveraging these agentic capabilities. So you have things like an agent to understand the different processes. You have an agent to extract information from the existing. If it's a drug manufacturing process, so you extract relevant piece of information from the documentation created for the drug manufacturing process, and then you create the different report sections that are required by the regulatory body, and then you submit it. So some processes are more attuned to or have a greater affinity to be automated by leveraging these agentic systems. However, I also want to point out that uh, while the expectation would be that, hey, if I'm able to automate, these systems, do I need the guy who was previously, doing this task of understanding, the regulatory requirement vis-a-vis the manufacturing process or the process to create the new treatment procedure and then create a report? The answer is yes and no. This is not going to replace the domain expertise that a particular person brings to the table, because it not only builds on generic procedural information, but also knowledge and information which is specific to an organization and how it has defined it to succeed in the marketplace. I know I'm out of time, so I'll quickly move on to the next couple of slides. So this is an example of, again, the processes relevant in the airline industry, and what you will see and notice is that even over here there are various processes which have a high potential of being addressed in terms of automating parts of it, leveraging these agentic systems. Now, I hope I am able to, pass on the message that uh, leveraging this skill is not limited to just the techie folks in an organization. Um, Even if you are a if you're a domain specialist, and I know a lot of you all will be looking at that as your potential careers, whether you're a mechanical engineers or you all are electrical engineers, etc., etc. uh, you, from a domain perspective, you would be using these systems as a consumer vis-a-vis the creators of these systems, who would be more technically inclined. However, irrespective of whether you're a consumer or a creator, you would need, if you're a consumer, you would need to know or appreciate certain aspects of the AI world and how these agentic systems work, so that you yourself can create these systems. Because we are moving to a world in which you do not need to be a coder to be able to create these systems. For example, if you are a creator as well, while it is amazing and central, to understand how these algorithms work to make them more efficient. You would still need to appreciate the domain side of things so that you bring out the value or you bring out something unique in the way you mix and match these capabilities to build some system. So, having said that, what I have out here is, the roles that are typically relevant in a, IT or a tech services firm. So, you would uh, identify certain central roles which are directly related to this agentic AI system, which is the data scientist or the data engineer or the ML ops engineer. However, as I said, you are looking at these systems creating software, for example, itself. So all these other profiles are also, exposed to this agentic world, and therefore it is incumbent on these guys to also pick up these technologies. So, for example, there is AI-based test automation that we are looking at. Similarly, if you look at threat intelligence, the because of the increase in the vectors that are now relevant from a security point of view, even the security products that are being created to circumvent threats are leveraging advanced algorithms and agentic systems to not only stop or prevent attacks, but also recover from any attack which may have gone through, for example, so on and so forth. So, whether it is an offering manager who brings or creates new offerings for the market, who needs to, analyze competitor offerings and use that information to create a new offering, to, other profiles that you see out here, all of these profiles are increasingly being required to leverage and harness the capability of AI in today's world. And as that matures, it will also become agentic in the future. Similarly, on the next two slides, I've taken examples from the automotive industry and the financial industry. So, whether it is, let's take quality control, for example, right? So, we've talked about, multimodal systems. Now, a lot of the quality controls that are realized on the shop floor or the manufacturing floor is determinant on visual cues of the systems that are operating. Now, again, obviously, you would use various, algorithms which are relevant in the vision world, and or vision-based models to be able to acquire information and then extract insights from it. Um, and as you develop these systems, these quality engineers may be able to define how these should be orchestrated so that his work becomes easier. Similarly, if you look at the logistics person, right? We talked about how uh, analytics is already embedded in various aspects of logistical planning. I mean, these are typical math problems, right? Determining the most optimum route, for example, from point A to point B, or determining which mode of commutation to take to transport goods from point A to point B, so on and so forth. So these are all mathematical, logistical problems, optimization problems, etc. And as you look at different permutations of such use cases and problems, you move into the agentic world where you would develop systems that could be utilized no matter the combination of variables which go to determine the problem scenario that you're trying to address. So what I'm trying to make you all appreciate is that, irrespective of even the kind of profile that you are looking in the future to adopt or move into, appreciating analytics and the world of AI is always going to be beneficial for you. Similarly, if you take the example of the financial services, and these are roles that you would typically find in a financial services firm or an investment banking firm. I'll just summarize this slide, in the form of the following: that central to investment banking are various quant-based models that are developed, to optimize the investment returns for an organization. And these are pretty complex scenarios which take into consideration various forms of risk models as well, towards determining the path to be followed, or the approach or the strategy to be followed. So you are seeing that very very advanced algorithms are used even over here, whether it is trading, etc., or anything to do with any investment product. uh, this is not going to be untouched by the relevance of analytics in general, and more specifically the agentic world of things. And with that, I'd like to end with a few inputs for you all. Um, I would like to emphasize that, I mean, just knowing AI is good, right, as a profession or a work stream, but the more you also know about the domain expertise, about the domain, is that will provide you with unmatched value. Do remember that you know uh, technology is something that we try and commoditize as we mature, right? So AI itself is getting commoditized. Obviously there'll be new ways of doing things which will get invented, and then we'll move towards those. So for example, right now, as I talked to you before, the challenges of that, of harnessing these agentic systems in terms of ensuring observability, reliability, etc., that has not been commoditized yet, right? So those are active research problems, and those are active problems which are being resolved in the marketplace. So there is always going to be things that you will have to learn and pick up and implement. um, the application layer, and this again talks about the business implication, or how you would utilize these algorithms to solve real world problems. So the application layer is where the differentiation and innovation shall thrive and shall come from. So the basis of model integration and customization and data engineering, and so these basic technologies and these skills will remain. However, you would want to build on top of them, leveraging these AI technologies and these capabilities to build systems that address real world use cases. Ethical AI is a growing field, but this, is a multidisciplinary field which, builds on aspects of philosophy, law, etc. So, addressing questions of, whether you should deny somebody, a particular product based on his, demographic parameters, etc. Uh, More importantly, problem solving, as you all have been trying to equip yourself with, is going to continue to be of paramount importance. And any kind of problem solving, right? So as simple as how do you get to college, for example, on a rainy day, to how do you get to point A, from point A to point B in the least amount of time. Trying to prototype those problems, and building solutions for it, codifying it, that is, there is no replacing that capability. And I would like to leave you all with a request to continue your inquisitive bent of mind, and to continue to explore these new evolving fields. And with that, I know I've been talking for a long time. I shall stop for any questions.
Yes. Thank you so much, Adarsh, sir, for sharing your valuable insights for on the future of agentic AI, its industry implication, and also your experience and perspective has given me, all the students, those who are in the meeting, a clear understanding of how AI is shaping businesses and what it meant for aspiring professionals in this field. I also truly appreciate your practical guidance and thought-provoking insights you shared with us today. So, before we move on to the Q&A session, we would love to see all your happy faces. Can I request everyone to quickly switch on your cameras for the snapshots, and then we will move on to the Q&A round, which will be of 5 minutes, and then we will quickly end today's session. Yes, thank you so much. I'll just quickly take the screenshot and then we'll move with the Q&A round. Yeah.
And I'm sorry, I forgot to put on mine, so I was talking without my video on all this while. But anyways,
Yes. So, uh, uh, yes. Yes, we can see you now.
so
Just few
team,
more. Yes, yes.
I mean, I just wanted to, share that if you have any questions, feel free. I mean, it can be anything related to the world of AI or enterprises as well. And I shall see if I have the knowledge to respond to you all. If not, get back to you all.
Yes, students, if you have any doubts, you can drop your questions on the chat box because we have kept that settings open that you can drop your questions to the host and co-host. So quickly, if there are some of the questions you want us to address right now in the meeting, you can text me or others, sir, any one of them.
I see
Yes, there
Chirag's
is.
hand up. Okay, you go ahead.
Yes, any questions from you, students? You can directly put a text to others, sir, or me. We can address this in today's meeting. Yes, students' questions. Okay.
How
Aditya
would
Singh
you?
has question. Yeah, yeah, you can go ahead. Yeah.
Yeah. Uh, actually, Rashika, I see questions starting from. I hope I'm pronouncing the name properly. Dheye. So, is that the first question, or I mean, do you want to curate it, or should I just go ahead and pick up? I think I'll do that. So, the first question is it still is it still good for going to mastering AI? See, you can. I don't think you can master anything, right? I've been doing this for over 20 years now, and with each, I mean, earlier it used to be a decade. Now it's maybe every 3 or 4 years there is something new. uh, so I would advise you all to uh, do what you're doing well, and learn as much as you can. As simple as that. Uh, Along the journey, if you can master it, so be it. About the lean project canvas, we don't know what to do in it. Okay, so this canvas, I think this is an out of syllabus question. I am not aware of this. It's not related to what I have talked about. My college is given us a deadline and we required to submit mentor signed documents. Okay, this I think is also out of syllabus, so to say. Is there a way to get chance directly like a? So yeah, I mean, Devendra, I mean, uh, we have a pretty large AI practice within IBM, right? I mean, we have also been in the frontier. It's not as popular as some of the other competitors, but there's a lot of good work that is being done in terms of opportunities. Uh, Coding sessions, there are internships, there are hackathons, which will elevate you in terms of exposure. And then there are also campus events that IBM conducts, etc. So that would be the route to go. I would recommend and encourage you to participate in these hackathons, etc. um, and take it from there. What are the ethical aspects to be considered? So, I mean, see, I did not touch, Aditya, I did not touch upon the ethical aspects. There are, it is use case specific, right? So, uh, and industry specific. So, like for example, it can be as simple as denying a person um, a product or of service based on certain characteristics which you have defined in the system. So, for example, let's say a simple example like classifying people as Gen X and Gen Ys and Gen Zs, right? Now, what if I don't, I mean, believe that I belong to that, categorization? Will I be happy with a company making a decision based on attributes of a presumed Gen Z category that I belong to and deny me something? So that is one, at one end. The other end is, for example, determining treatments for patients depending on their capability to pay instead of the quality of treatment, right? So there are various ethical aspects. It's a vast field, and but it's a very important questions, and these also affect not only this so-called agentic world, but also the AI world itself, and statistical modeling as well. So it is very relevant, but it is very case specific, and therefore you need to have representation of people from different walks of life who are building such systems. I'll move on to the next question: how to integrate AI concepts with cyber. So, see, cyber, um, I mean, security inherently also uses various algorithms to, find possible, exposure or vulnerabilities in systems, and then, make use of it. So there are various algorithms for that. You scan systems, and then you find, points of increased vulnerability, and then you attack those things, right? So, um, uh, AI is very, very relevant in cybersecurity, both from a prevention perspective as well as from a hacking perspective. So again, this requires a separate discussion or a top. I mean, a lecture by itself. But try and go through some of these, blogs online or certain books, etc. But it's very relevant to cybersecurity as well. Have you provided a full day internship? I mean, when you're saying you, I believe you're referring to the company I represent. So I unfortunately am. I belong to the a very specific group called the Solutioning Group. But there is a dedicated team which looks at internship, etc., and university relationships. So I think you should pursue that through your university, because IBM does have internship relationships with various universities. Journey from linear regression to transformers very long? No. uh, Stop doing linear regression, pick up books, or look at the transformer architecture to understand it. I know you all also had a reference to this in the previous session, but I mean, suffice to say that you don't, I mean, you can obviously, I mean, it's obviously a benefit if you understand the basics of statistics, and before you move on to the transformer details. Of course, I mean, understanding neural networks is important and is central. But if you start off with trying to understand the transformer architecture, you can do it. Also, it depends on how you want to use that information. So if you're using it from a point of view of creating alternate architectures, then yes, it is hard. But if you're using it to appreciate where systems that are built on transformer architectures rather than other architectures, and what are the differences, then you don't need to become get too technical with the mathematics side of it. What is a good practice of agentic AI? Drag and drop method or scratch by coding? See, again, this depends on what you want to do, Roshan. So, if you are a person like if you are a domain person, right? You don't need to learn how to code these systems. I mean, that is why the GUI interface was built, right? And as I mentioned, the human computer interface evolving to an extent where you provided just a command and the system creates whatever code it needs to create for you is becoming real. So, but yes, if you are building such systems, then you need to learn how to code. Um, what are the other coding technologies we can use to create AI projects in a simple way? I I don't know how to answer this. I mean, so if you're talking of coding technologies, I mean, any programming language is a good language, right? So, I mean, it's rather ironical. I started my career with Java and C, and then moved on to various other, systems like SAP and ETL and reporting tools, and then advanced analytical tools, and then now I'm back to coding in Python and using classes and objects. So use any coding technology is what I would suggest, but just keep pushing the boundary further. Yes. So what are the basic things or skills that will remain the same? See, so I mean, if you're looking to create such things, maths is important, right? If you're not looking at creating such things, concentrate on your domain stuff. So if you're, let's say, I mean, see, in engineering, you're all exposed to mathematics, is what I'm presuming, right? So whether you're a mechanical engineer or a civil engineer, mathematics is core. So the only differentiation is that if you're building these AI systems, you within maths you look at calculus and algebra, etc. Um, but otherwise, that remains core. As I said, problem solving remains core, and then your domain thing. So what I would strongly recommend is do not change what you want to do just because of these buzzwords. Rather, do what you want to do and see where it gets you, right? Learning a bit about AI is not very tough. You can do it in a span of 2 or 3 months maximum. But the differentiation that you would get by doing what you want to do is something that would not be easily replicable. Can you share an efficient roadmap for learning AI? I know there are quite a few questions, so I'll try and now skip a few. I don't have an answer. I will. I mean, but start with. I mean, as I said, look at the different modalities of systems. So, how do vision models work? How do text model work? How do these uh, uh, um speech to text and text to speech models work. So basically, audio signal processing, uh, uh, vision processing, and text processing. Basically, look at those things to start with, and then move on from there. I want to know your opinion on generative AI. Also, what do you think it is different from? So, agentic AI leverages generative AI. So, generative AI is the output of or the result of using these transformer models, which are further divided into autoregressive models and so on and so forth, right? So, um, um, agents use those capabilities of these foundation models. How does reinforcement learning enhance? So if Sadiq, I mean, if you are looking at reinforcement learning, please continue your focus on this. Newer techniques like ORPO, DRPO, which are successors of this reinforcement learning, are going to be the mainstay of the AI world in over the next few, I think, quarters at least. So please focus on that. If you want to start an IBM field, how do we need to prepare? Accurate roadmap, my process, placement of AI, part of the team. Uh, I know team Amin and Rashika, you will have to provide a cutoff, but just let me know when you want to
Yes.
stop. Um,
Yes.
can I be able to take the commerce industry, or what grades like the work for a CA? Yeah, yeah. I mean, so I talked about AI in the finance industry, right? So I mean, so AI is a logical progression of statistics, is how I would define it. Statistics is very relevant in the financial industry, in commerce, right? Wherever you have a lot of numbers, statistics will have a play. AI will have a play. So people from a size, so you will not. So this is what I'm trying to emphasize. Do not believe that you cannot understand mathematics just because you believe that you've taken a non mathematical stream. So if you've taken, let's say, biology or commerce or whatever, that doesn't mean that you don't understand these things. So, but yes, you will have to invest some time to try and understand them, but it is very doable. But it is very relevant to any field, right? Whether it's even, I mean, I can give you multiple examples of how AI is being used in the medical field, for example. So please try and adopt and be open to such technologies and move, transformation that are occurring in the world. What is intelligence? Okay, how to fight reactive, deliberative? See, so again, Siddiq, I can answer this question, but do not be limited by these. See, definitions are given to concepts so that people can understand them better, right? Uh, First, try and understand AI, what these agents are, and then move on to the types of agents. I mean, basically, what I'm trying to say is that the types of agents will become obvious as you progress from learning of how to, build algorithms, how to leverage AI for, solving real world use cases, and then going on to various types of, agentic patterns. Uh, mm, Yeah, see, I would not compare, building or consuming against each other, right? There are ample opportunities for both. All I'm saying is that if you are creating AI, you obviously will go deep into this field of science, vis-a-vis somebody who is leveraging AI to further his cause. So, for example, if I'm looking at, I mean, if my knee is aching, I just need to look at what are the possible causes of knee pain, and then look at various home remedies. I don't need to learn AI, to be able to get my answer in that regard, right? But I need to know how to ask my question to this model so that I get a relevant and a required answer that is beneficial for me. So knowing how to ask and how to manipulate or use the system is important. So that is where the consuming side of AI comes into picture. There's drag and drop. So yes, I mean we are building GUI capabilities of building agents. So the future will be GUI based. The future will be text based. I mean, so speech based. So you will provide commands and things will get created. But it is a long way to go. I mean, we are just touched the tip of the iceberg right now. There will be time before which these will become mainstay. Okay, so this we've covered. Okay, Android developers, not my area of expertise. How do we improve real-time prediction reliability in hand gesture recognition with noise and partial inputs? Okay, so I mean, I don't get your name, but this is a pretty technical question in terms of gesture recognition and things to do with object detection and spatial correlation of those objects, in terms of gestures, etc., and in noisy and partial input. So I mean, I'm guessing that you are deep into this field, but I think that we'll have to take this offline. If you can provide me your name, I can't